Good evening, students. I am Dr. JSVN Manikumar, Mathematics faculty in ACE Engineering Academy. Today, I am here to give you a video lecture on the preparation strategy, of the topic probability and statistics in engineering mathematics. This video lecture will be divided into two sessions, today and tomorrow. In these 2 days, we will discuss the preparation strategy of this particular topic and some important concepts. Along with that, we will discuss some questions, means some previous gate questions and some different examples also. In these 2 sessions, I will cover the overview, on complete topic, I will give you brief overview also. Okay. Now, coming to, if you have any queries or doubts, you just send to this mail ID. Your queries you can send to this mail ID, jmanikumar@aceengineeringacademy.com. Now, the reference books, what you have to follow for this particular topic is ACE Academy material, Fundamentals of Mathematical Statistics by S.C. Gupta and V.K. Kapoor. This book provides good theory and content. Probability and Statistics for Engineering and Sciences by J.L. Devore. Probability and Statistics by DeGroot and Scrovish. Particularly, these books, generally along with this, number of standard books which are available in the market. Some books will provide good content, means good concept, means in-depth concepts and theory. Some books will provide good number of examples, and some books will provide exercise problems and real applications also. But generally in competitive examination, how the material is helpful to you? Generally, one book according to your syllabus. Suppose for any GATE examination or for ESE or any other competitive examination, according to your syllabus, only one book will not provide complete, see what is sufficient to you, okay, how much area is sufficient to you, and some number of examples required, number of problems required. One book will not provide, okay, one book will not provide the complete information what is required to you. But generally in material, we will provide that information. What is required to you, how much content is required to you, that content we will provide here, and along with that, number of examples, exercise problems, classroom practice problems, and number of previous gate questions also we will provide. Okay, the material will be helpful to you like this. Now, coming to the main contents. Now, let us start the session. Before that, generally probability and statistics is one of the important topic in engineering mathematics. You know, engineering mathematics weightage in GATE examination is 15 marks, and probability and statistics weightage is 3 marks. Sometimes they are asking 4 marks, sometimes they are asking 2 marks also. Okay, but more on average they are asking 3 marks, means one mark and 1 2 mark questions. Sometimes 4 marks, sometimes 2 marks also. Okay, but average information. So according to the previous GATE questions history, I am giving this information to you. And my dear students, generally probability and statistics, particularly for this topic, some of the students are feeling, this topic is very easy. Some students are feeling generally this is very tough, but most of the students are feeling it is one confusing area. Probability is a confusing area. What is the reason? So each and every problem, no doubt. Suppose if you solve one problem, next problem is looking different from the previous one. Third one is different from the first two, like that. Even if you solve 1000 problems also, if you open the next problem, no doubt that problem is different from the previous 1000 problems. That's why most of the students are feeling probability and statistics is one confusing area. How to overcome this situation? Okay, how to overcome this problem? Only thing is you have to follow the concepts more clearly. You should be perfect in the concept. Thoroughly you have to go through the concepts. Okay, if you are perfect in the concepts, then problems will become very easy to you. First you follow the concepts clearly, and then you open all previous gate questions, okay, if you are able to solve all the questions clearly, definitely your confidence level will, no doubt, your confidence will go to the next level. Okay, I am giving assurance to you accordingly. Particularly, follow the concepts clearly. If you are perfect in the concept, problems will become very easy. Now, coming to the session, have a look here. Okay, what we are going to discuss here. Main contents in this particular topic, what I am going to give you here. Basic concepts on probability, conditional probability, Bayes theorem. Random variables. Random variables are two types, discrete and continuous. And discrete distributions. Okay, after this, in tomorrow's session also we will cover the remaining part. Today, I will try to finish all this. Okay, up to continuous random variable, or if possible discrete distributions also I will complete today. Okay, now coming to the definitions, basic definition. Generally, if you open any standard book, the first definition in the book is random experiment. Many students have doubt, what is the general meaning of random experiment? Okay, why can't it be experiment only? See friends, experiments are generally two types. One is the deterministic experiment, second one is random experiment. What is the deterministic experiment? Deterministic experiment means outcome we can predict. Outcome is predictable. We can predict the outcome what it is. So what it is, for examples, you see some examples. Sun rises in the east. Yes, sun always rises in the east only. Okay, unless there is a change in the arbitrary motion of the planet, sun always rises in the east. We can predict the outcome. So, okay, if I ask a question, what is the chance of sun rises in the east? If I ask a question like this, no doubt, my question is a foolish question. Why? Sun always rises in the east only. Here, there is no chance to ask the word chance. Okay, here no question. Okay, sun is always rises in the east. That is determined, predetermined. Delhi is a capital of India. Yes, this is also predetermined. 2 plus 3 is always equal to 5. Okay, what is the chance of, if I ask a question, what is the chance of 2 plus 3 is equal to 5 means, again, there is no meaning in this question. So, here word chance we will not use here, not required, because all outcomes are very clear. Now, second type of experiment, random experiment. You see, in this case, outcome is not predictable. We will not be able to predict the outcome what it is. For example, tossing a coin. Okay, if you toss a coin, outcome may be head or tail, but we don't know what it is exactly. Similarly, if you throw a die, here also same. Outcome may be either 1 or 2 or 3 or 4 or 5 or 6, but we don't know what it is exactly. So, result of the game between two teams. I think today there is an IPL match between SRH Hyderabad and Gujarat, I think so. Okay, who is going to win in sense? We cannot predict the result. Okay, all such experiments are called random experiments. Here there is a possibility. We can ask a question here. Well, here I can ask a question. If a coin is tossed, what is the chance of getting a head? Or what is the chance of getting a tail? Because outcome we don't know, we can ask such questions. Okay, what is the chance of winning SRH? Okay, or what is the chance of winning Gujarat Titans? Like that. Okay, so that is the difference between deterministic and random experiments. Now, coming to the particularly the probability will define for the random experiments only, because the word chance is possible for the random experiment only. That's why, okay, before going to define what is the probability, first you should know what is sample space and what is event. The set of all possible outcomes in a random experiment. If you take all possible outcomes as a set, that is called sample space. It is denoted by capital S. Every outcome of a random experiment. Okay, all possible outcomes is a sample space. Every outcome of a random experiment is called an event. It is denoted by capital E. Clearly, every event is a subset of S, like this. I have taken some examples. Suppose if you take 3 events, yes, no doubt, complete probability is completely related to set theory. If you follow set theory logics carefully, no doubt, problems in probability you can solve very easily you can solve. Suppose you see here sample space is like a universal set. Every event is a subset of the universal set. Every event is a subset of universal set. Or Sometimes we can represent area wise also. Sample space is nothing but the total area and event is nothing but the required area. What is, suppose you have 4 acres land. Among 4 acres land itself is the entire sample space, total area. Among 4 acres land, only 1 acre is fertile land. Only 1 acre is fertile land means, suppose my question is, okay, suppose my question is, what is the chance of fertile land? What is the probability of fertile land means 1 acre out of 4 acres. So, here total area is nothing but a sample space, required area is nothing but an event. To solve some problems, okay, using set theory logics, you can solve some problems easily. To solve some problems area wise, using area concept also, we can solve some problems easily. That's why I am giving these two, I am giving set theory information and area wise information also. It may be helpful to you. Now coming to the example, if a fair die is rolled, then sample space capital S is nothing but, here there are 6 outcomes, maybe 1, 2, 3, 4, 5, 6. Suppose one event of getting a number 5, that is nothing but a singleton 5. E2, another event, if you define like this, event of getting an even number, that is 2, 4 and 6. Okay, sample space and events we can define like this. Now coming to the probability definition, already you know, but once again this is a recollection of your knowledge. Probability of an event, probability always will define for the event only. Event is a part of a sample space. Probability of an event capital E of a sample space S in a random experiment, it is denoted by probability of an event P of E is equal to number of elements favorable to E. How many elements which are favorable to E, that you can take in numerator. Denominator is the all possible outcomes, means total number of elements in a sample space. Simply what it is, so denominator is nothing but the universal set, all possible elements of universal set. Numerator is nothing but what is required to you in that you can take. Suppose number of E1 required, number of elements in E1, I will take in numerator. E2 required, number of elements in E2, I will take in numerator, like that. Simply numerator is a part of the denominator. So numerator is a part of the denominator. Whenever the question given to you, first you write n of s. How many elements are in sample space? All that number you can take in denominator first. And numerator always comes from the question. So one simple identification. Denominator always comes from the data. You can fix the denominator first using the given data. Numerator always comes from the question only. What is required to you? We need to find the probability of that event. Is it? For example, you see, if a fair die is rolled once, the probability of getting an even number, very clear. Fair die is rolled once means whenever the question, if they ask like this, fair die is rolled once means, yes, immediately what is sample space? Yes, sample space contains 6 elements like this. What is our question? Our question is the chance of getting an even number. Okay, what is the, how many favorable cases to get an even number? 2, 4, 6. So number of favorable cases, denominator is the all possible outcomes, numerator is the number of favorable cases. Here to get an even number there are 3 favorable cases, 3 by 6, 1 by 2. Numerator is always a part of the denominator. Keep that information. Some observations, some observations on probability, some axioms of probability. Probability means chance. Generally, what is the minimum possible chance? 0%. 0% means what it is? 0% means what it is? 0 per 100. Is it? 0 by 100, 0 per 100 means 0. Okay, what is the maximum possible percentage? Damn sure, I will come there. Generally, we are using these sentences. 100% means what it is? 100 per 100. What it is? 1. Very clear. So the chance is generally oscillating between 0 to 100% means the probability is always in between 0 and 1. The minimum probability is 0 means that is no chance. Maximum probability is nothing but 1. So P of the probability is in between 0 and 1. If P of E is equal to 0, in that case that event is called impossible event. If P of E is equal to 1, in that case that is called sure event. Now coming to E complement, probability of E complement is nothing but 1 minus probability of E. probability of the entire sample space. So a probability of entire sample space means the maximum possible percentage, that is nothing but 1, because we are covering the whole universal set. And probability of null set means it is an impossible event, that is 0. Now you see, if E1 and E2 is equal to 5, then E1 and E2 are called mutually exclusive events. Sometimes intersection of two sets may be, intersection of two events may be 5. In that case, E1 and E2 are called mutually exclusive. For example, you see, for example, if a single coin is tossed, if a fair coin is tossed, if a fair coin is tossed, what is sample space? Sample space is nothing but all possible outcomes at and tail. My question is here, one event I am writing here, E1 is equal to event of getting ahead. Event of getting ahead means what it is? It is single, it is H only. E2 is equal to event of getting a tail. Event of getting a tail. What it is? What is E1 intersection E2 here? Is there any element which is common in both E1 and E2? There is no element in common. Here E1 intersection E2 is equal to 5. Therefore, E1 and E2 are mutually exclusive events. In case of mutually exclusive event, whenever the intersection is 5, if you take the probability what it is, P of E1 intersection E2 is nothing but P of 5. Probability of null set is 0. In case of mutually exclusive events, you can obtain this case. Okay. Now, some axioms, that is addition theorem for two events, P of E1 union E2. Generally, P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. Okay. In case of mutually exclusive events, intersection will be 0. P of E1 intersection E2 is 0. You will get P of E1 plus P of E2 only. This is addition theorem for 3 events. Okay. In 3 events case, you can apply the addition theorem. And P of E1 intersection E2 complement is nothing but P of E1 minus P of E1 intersection E2. All these axioms are from set theory only. See, almost all set theory axioms are applicable in probability also. Okay. This is nothing but N of E1 union N of A union B union C. Is it N of A union B union C formula or not? Is it N of A union B formula or not? And particularly while solving the problems, one simple logic you need to follow. Sometimes we are using plus operation, sometimes we are using product operation. Particularly union, particularly plus means OR operation. Plus indicates OR operation. Or either A or B. In such case, you can use the plus operation. Okay. Product means generally AND operation. AND means if you are continuing the task. Okay. A and B work. A have to work, A have to do, and B have to do. In that case, because A and B both together have to do the work in the sense, okay, in that particular case, I will follow product operation. Either A or B, in that case, I will take plus operation. In problems, I will show you more clearly when plus is applicable, when product is applicable. Generally, you may confuse. Some problems you are taking plus operation, some problems you are taking product operation. Okay, this is a simple way to avoid your confusion. If you use OR operation, generally plus. AND operation means if you continue the task, that is product. Okay. Now coming to this. Now coming to, we'll discuss some problems. Some of them are previous gate questions also. See this. If 3 fair dice are rolled simultaneously, find the probability that sum of the numbers on the dice is 16. See, 3 dice are rolled. 3 dice are rolled simultaneously. Some appear means number on first die plus the number on second die plus the number on third die must be 16. Okay. 3 die problem means what would be the denominator? Already I told you. Whenever the problem given to you, first you have to fix the denominator. Okay. What is n of s? First you have to fix. Solution. This is 3 die problem. What is n of s here? N of S is nothing but 6 cube. For single die, okay, for single die means I will give you more clarity like this. Suppose the first die is marked with the numbers 1, 2, 3, 4, 5, 6. Second die is 1, 2, 3, 4, 5, 6. Third die is 1, 2, 3, 4, 5, 6. I will not write all the cases, not required. Leave it. Only for to only for the explanation, to give you a clear cut information, I am writing like this. Now you say this. Whenever 3 days, suppose if single die is rolled, denominator is nothing but 6 outcomes only. 2 dice are rolled means 6 into 6 will get 36 outcomes. Means 36 means what it is? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Like that. 2, 1, 2, 2. All such possibilities you will get 36. If 3 dice are rolled, okay, we will get 6 cube. 6 into 6 into 6, 6 cube. Means what it is? 1, 1, 1. Like that. Suppose if you write a sample space, maybe 1, 1, 1, and second one is nothing but 1, 2, 2. Like this, if you write like this, last one is nothing but 6, 6, 6. Like this, 6 cube possibilities will get, means 6 cube means 216. N of S is nothing but 6 cube, 216 possibilities. This is denominator. Okay, this is denominator. Now coming to the numerator. Numerator is always a favorable case. Numerator always comes from the question. What it is? Among these 216 possibilities, already I told you, numerator is a part of the denominator. Among these 216 possibilities, how many of them give sum 16? How many of them give sum 16 means generally how to verify here 5, 5, 6 like this. Okay, 6, 6, 4 like this. If you verify like this, how much time it will take? No doubt, it is not a suggestible way. To find the number of ways, I will give you one simple technique for 3 days problem. Say this. Particularly for 3-day problem, I will give you number of ways. You see, if the sum is R, sum R, number of ways. Suppose if you represent the sum is R, number of ways I am writing. If the sum, generally for 3 days problem, what is the minimum possible sum? 3. 1 plus 1 plus 1. What is the maximum possible sum? 6 plus 6 plus 6, 18. So minimum sum is 3 and maximum sum is 8. 18 means sum is oscillating between 3 and 18. Okay. Using this table, I will give you one simple table. Using this table, every problem you can solve on 3-day problem. That is 3 less than or equal to r less than or equal to 8. If the sum is in between 3 and 8, we can write this formula directly, r minus 1 into r minus 2 by 2. If the sum is 9 or 12, means this is applicable for 3 to 8 only. Direct answer 25 ways, 25. If the sum is 10 or 11, there are 27 ways. Again, see, 3 to 8 completed, 9, 10, 11, 12 completed. Now 13 to 18. If 13 is less than or equal to r is less than or equal to 18, 19 minus r into 20 minus r by 2. 19 minus r into 20 minus r by 2. Okay. Now you say this. What is required here? Sum 16. Sum 16 means here r is equal to 16. R is equal to 16 means it is in between 13 and 18. 13 and 18 means what is the formula here? So r is equal to 16 means 19 minus r into 20 minus r by 2 means here number of ways is nothing but, therefore the number of ways, here r is equal to 16. Here r is equal to 16. Therefore n of e is equal to number of favorable cases, 19 minus 16 into 20 minus 16 by 2. 19 minus 16 means what it is? 3 into 4 by 2. What it is? 6. Therefore, what is required probability? Therefore, required probability is nothing but is equal to n of v by, that is 6 by 6 cube means 216. 6 by 6 cube. 1 by 36 is the answer. For 3-day problem, you can follow like this in simple way. Okay, which option is right? Option A is correct. Okay. Are you clear so far? Now coming to the next problem. Find the probability that a leap year will have exactly 52 Mondays. Exactly 52 Mondays. Yes, is missing. Mondays. Okay. Exactly 52 Mondays means generally leap year. What is leap year here? Solution. Leap year means, 366 days. 366 days means 364 plus 1 plus 1. Why I am writing like this in this is, up to 364, 52 weeks are counted. 52 Sundays, 52 Mondays, 52 Wednesdays, like that. So 2 additional days are there. What is our question? Leap year will have 52 Mondays. Exactly 52 Mondays means here there is a possibility for 53rd Monday also. Why? Why there is a possibility for 53rd Monday? Particularly you see, suppose if the 364th day ends with Sunday, 365th day is a Monday. So in that case 53 Mondays are possible. So exactly 52 Mondays means how to understand? There is no chance for 53rd Monday. Okay, first you should be clear in that. Okay, P of probability, P means probability of exactly 52 Mondays means probability of exactly 52 Mondays is equal to P of no chance for, no possibility for 53rd Monday. 53rd Monday. Is it? Probability of no chance for 53rd Monday means simply what it is? It is the probability of non-occurrence. Okay, probability no chance for 53rd Monday means probability of non-occurrence. Means complement. Probability of non-occurrence is nothing but 1 minus probability of occurrence or not? That is 1 minus P of 53rd Monday. Probability of non-occurrence is nothing but 1 minus probability of occurrence. 53rd Monday. Okay, now coming to 53rd Monday possibilities, I am writing here, you see. These 2 extra days are there or not? These 2 extra days. Okay, these 2 extra days means in these 2 extra days only 53rd Monday possibility is there. So these 2 days may be, suppose if 364th day ends with Sunday, this may be Monday. Okay, Monday Tuesday combination, or these 2 days may be Tuesday Wednesday combination, or Wednesday Thursday combination, or Thursday Friday combination, Monday Tuesday, Tuesday Wednesday, Wednesday Thursday, Thursday Friday, Friday Saturday combination, Friday Saturday combination, Saturday Sunday combination, again Sunday Monday combination. Okay, these 2 days may be consecutive days, may be like this. Now what is the question here? Probability for 53rd Monday. Total how many possibilities are there? That is 1 minus total possibilities are 7. Out of 7, 53rd Monday, out of 7 how many Mondays are there here? Here 1 Monday is there here, 1 Monday. Okay, out of 7 there are 2 possibilities for Monday. 1 minus 2 by 7, what it is? 5 by 7. Are you clear? This is a way to solve this problem. Generally one may confuse. Then probability of leap year will have exactly 52 Mondays in the sense. Generally a leap year will have by default 52 Mondays. So generally what you are thinking? It is a sure event, so probability is 1. Okay, some of you may think like this. That's why one of the option has given as 1 also, but that is wrong. Okay, which option is right? 5 by 7 is correct. Okay, next you see the problem. an integer x is selected randomly from 1 to 100. See, whenever the data given, first you fix the denominator. An integer x is selected means how many integers we are selecting? Only one integer, we named it as x. An integer x is selected randomly from 1 to 100. It may be 1, 2, 3 up to 100. Means what it is? Okay, we are selecting 1 among 100. So n of s is nothing but we named it as x. Leave it. Okay, one integer we are selecting out of 100, that is nothing but 100 C1. 100 C1 is nothing but 100 only, that is denominator. Now coming to the numerator. Numerator always comes from the question only. Find the probability that the selected integer x satisfies the condition x plus 100 by x is greater than 29. Okay, means what is the meaning? What is numerator here? Among these 100 integers, the number of values of x which satisfy this condition, that comes in numerator. Okay, what are the favorable cases here? Okay, here favorable cases satisfies the condition. What is the condition? X plus 100 by x is greater than 29. Means what it is? X square plus 100 is greater than 29x. That implies x square minus 29x plus 100 is greater than 0. That implies x minus 4 into x minus 25 is greater than 0. Okay, x minus 25 is, see, product of two factors is greater than 0 means when it is possible, either both may be positive or both may be negative. That is x minus 4 greater than 0 and x minus 25 greater than 0. This is one case. Or x minus 4 less than 0, if both are negative, in that case also product is positive. X minus 25 less than 0. Okay. X minus 4 greater than 0 means x is greater than 4 and x is greater than 25. A number which is greater than both 4 and 25, when it is possible, a number which is greater than 25 which is greater than 4 also. What is the common value here? Common x here, x greater than 25 is correct. Here, coming to this, here also. X minus 4 less than 0 means x less than 4 and x less than 25. A number which is less than 4 and it is less than 25 also means when it is possible, what is the common number here? A number which is less than 4 which is less than 25 also. Now, among 100 integers, all possible values which are greater than 25 satisfies this condition, and all possible values which are less than, all possible values which are greater than 25 satisfy this condition. R means plus operation, already I told you, either this or this, or all possible values of x which is less than 4 also satisfies. So after 25 how many values are there? 26 to 100 means 75 values. Before 4 how many values are there out of 100? 1, 2, 3, 3 values. Here 75, here 3. So therefore what is required probability? Required probability P of A. Denominator is already fixed, that is 100. Numerator is nothing but here 78 and here it is, here denominator is 100, here 75, there 75, here 3, 75 plus 3, that is 78 by 100. Is it? 78 by 100 is the answer, means 0.78. 0.78 is the right option. Option C. By mistake D was printed. Option C is correct here. Okay. Next, coming to this problem. 4 pair coins are tossed simultaneously. The probability that at least one head and at least one tail will turn up. Okay, think about that problem. Are you clear? Four pair coins are tossed simultaneously. The probability that at least one head and at least one tail will turn up. Simple. 4 coins. Whenever one coin is tossed, denominator is 2. If 2 coins are tossed, denominator n of s is 4. If 4 coins are tossed, what is n of s here? Solution. Here n of s is equal to, for single coin, denominator 2, for 2 coins 2 square, 3 coins 2 cube, 4 coins 2 power 4, n of s is equal to 2 power 4, 16. Okay, numerator is a part of the denominator. 16 possibilities I will not write, but I will show you just 1 or 2 cases. Sample spaces I am trying to write. This is a sample space. Among 16, this is one case. All outcomes may be heads. This is one case. Or all outcomes may be tails. This is also one case. Now coming to the numerator. Numerator always comes from the question. What is the question here? The probability that at least one head and at least one tail will turn up means what it is? P of at least one head and at least one tail. Okay, simple logic you think carefully here. Denominator 16. At least one head and at least one tail means you have to observe both head and tail combination in each and every outcome. See this. Here there is no tail here. All are heads only. Here all are tails only. All are heads means is it a favorable case? Definitely it is not a favorable case. At least one head and at least one tail required in sense here no tail appears here. So this is not our favorable. Both head and tail combinations you have to observe. Simply what is the meaning here? In each and every favorable case you have to observe both head and tail combination. But here only heads are there, no tail is there. This is not a favorable case. Here only tails are there, no head is there. This is not a favorable case. Apart from these two, okay, among 16, apart from these two, in remaining 14 cases, definitely we can observe both head and tail combination. So remaining 14 cases are, all remaining 14 cases are favorable cases. So 14 by 16, 7 by 8 is the answer. Are you clear? Now coming to this, next problem. 7 car accidents occurred in a week. What is the probability that all they occurred in same day of the week? All they occur in same day of the week. 7 car accidents occurred in a week. Solution. So week means for a week how many days are there? Okay, so that I am taking like this: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, na? Okay, Sunday, 7. Okay, 7 car accidents occurred in a week means on Monday, how many possibilities are there for the accident? Okay, all 7 car accidents, see, what is the number of possible accidents? Number of possible accidents occurred on Monday. On Monday there are 7 possible because 7 car accidents occurred in a week given. Denominator I have to write the total number of possibilities. All 7 car accidents may occur on Monday only, we don't know. That's why for Monday we have 7 possibilities are there. Even for Tuesday also, and we are following AND operation here, you see. The possibilities on Monday and probability on Tuesday because all weeks you have to cover. We are continuing the task. We should not follow our operation here. Means number of, see, possibilities on Monday and possibilities on Tuesday and possibilities on Wednesday. Means I have to follow product operation. On Tuesday also we have 7 possibilities. Okay. On Wednesday also you have 7 possibilities. I am writing denominator, don't confuse, because denominator is the all possible accidents. Okay. All possible ways. So Wednesday also 7 ways. Thursday also 7 ways. Okay, that is also 7 ways. And Friday also 7 and this is also 7, this is also 7. So what it is? 7 power 7. Therefore n of s, all possible ways are nothing but n of s is equal to 7 power 7. Now numerator is always comes from the question. What it is? What is the probability that all they occur in same day of the week? Means what it is? For all the 7 accidents, we have to choose 1 week out of 7 weeks, 1 week out of 7 days. So total how many days are available? Monday to Sunday there are 7 days are available. We have to choose all the occurring same day of the week means we have to choose one day among 7 days. That is n of e is equal to, that is nothing but 7c1. Therefore, what is required probability? Required probability is nothing but 7c1 by 7 power 7. 7c1 value is 7. 7 by 7 power 7, 1 upon 7 power 6. So, which option is right? Option B is correct. Okay. Next, if a card is drawn from a pack of well shuffled 52 cards, find the probability that the card is a spade or a special card. Spade or a special card, either a spade or a special card. What is special card? Okay, you know spade. Okay, spade means spade is a black colored card. Okay, how many spades are there? 13 spades are there, you know. In spade there is a king, queen, okay, king, queen, jack, ace, okay, 2 to 10, up to 2 to 10, you know. Okay, spade is a shape like this, you know already. Okay, now what is a special card? Special card is nothing but king, queen, jack, ace, these are special cards. These are special cards means in spade there are 4 cards. In diamonds also there are 4 cards. In clubs also there are 4 cards. Next, spade, diamond, club, one more. What it is? Spade card, club card, diamond card, and one more. This is also 4. What it is? Now total for 16. Total 16 in the sense. Now the question is probability that a spade or a special card. Denominator is nothing but 52c1. Why 52c1? Why 52c1? 52c1 is nothing but we are drawing one card among 52 cards. That's why 52c1. Sorry, here one more. I did not write. Heart. Spades 4, diamonds 4, clubs 4, and hearts also 4. 4 means there are K, Q, J are special cards. There are 4 spade special cards and 4 diamond special cards, 4 club special cards and heart special cards. Okay, like 52c1. Now what it is? It is a spade or a special card. Spade or a special card means how many spades are there? 13 spades are there. 13c1. Special cards. How many special cards are there? There are 16 special cards. That is 16c1. Okay. Now spade or a special card, here you follow, actually you need to apply addition theorem, but no addition theorem required. Okay. Try to avoid formulas every time. Logically you follow. Here you see one thing. These are spades, these are special cards. Okay. King, queen, jack, ace. You see, in spades, king, queen, jack, aces are counted. These 4 cards are counted in spades. These same 4 cards are counted in special cards also. We are counting spade cards, we are counting these 4. You are counting these 4 since these 4 in special cards also. Means what we are doing here? In spade, these 4 are counting. In special cards also these 4 are counting. Means we are counting 2 times. Oh, but we have to count only one time or not? That's why these common elements you can subtract. How many common elements are there? 4 common elements. That is 4c1. Why c1? Means we are choosing only one card. That's why 52c1 in the denominator. That is 13 plus 16 minus 4 by 52. That is 29 minus 4 is 25 by 52. Okay. This is 25 by 52 means option B is correct. Now you see one thing. You can ask a question. Actually according to the rule, I have to apply addition theorem for two events here. See here. Say this. Addition theorem for two events I need to apply actually. What it is? P of, suppose if E1 is the event of a spade, R means union operation, either A union B means either A or B. E1 union E2, suppose E2 is a special card. What is the formula? P of E1 plus P of E2 minus P of E1 intersection E2. How it comes? From this logic only. From this logic only. What it is? P of E1 means how many spade cards are there? 13 C1 by 52 C1 probability. How many special cards are there? 16 C1 by 52 C1. Minus how many spade cards which are special cards also? There are 4 spade cards which are special cards also. That is 4 C1 by 52 C1. Same answer or not? Same answer. But instead of doing like this, simply whenever either or case, if you observe, whenever you observe either or case, first you write the first event probabilities, first event favorable cases you can write, plus second event favorable cases you can write. If there any common element, you can subtract the number of such common elements. Or if there is no common element, means how to understand those events are mutually exclusive. In that case, common elements are 0. You just keep it as it is. If there any common element, you can subtract the number of common elements. Otherwise, you just keep it as it is. Okay, that itself is an addition theorem application. Okay, no need to write addition theorem always. Are you clear? There are 5 different letters and 5 addressed envelopes. If the letters are put at random in the envelopes, okay, 5 different letters are there and 5 addressed envelopes are there. 5 if the letters are put at random in the envelopes, okay, the probability that at least one letter is placed in correct addressed envelope is correct addressed envelope. Okay, what it is that we have to identify. But before going to write the solution of this, first you should know D arrangements. D arrangements means what it is. Suppose you see there is a letter 1, this is envelope 1, and this is letter 1. Actually this letter 1 is for, I have to post the letter 1 in this envelope 1 because already it is addressed envelope, and I have to post the letter 2 in envelope 2. By mistake, if you place in wrong way, if you put them in wrong way means how many such, see, if all letters are arranged in proper way, suppose if you arrange letter 1 in envelope 1 and letter 2 in envelope 1, no doubt that is a proper arrangement. But improper arrangement means no one is placed proper way, no one is placed in proper way. No one is placed in proper way is called D arrangement. So, okay, if no one is placed in proper way means letter 1 is arranging a place in envelope 2 and letter 2 is placing in envelope 1. This is D arrangement. How many such D arrangements are there? We are placing letter 1 to E2 and letter 2 to E1 means one such D arrangement. Suppose 2 objects. Here 2 objects means 2 letters. For 2 objects, suppose D2. D2 means D arrangement of 2 objects. How many D arrangements? 1. Don't confuse. Sir, letter 1 we are placing in E2, letter 2 we are placing in E1 means 2 D arrangements. This is one, don't count like that. We are placing letter 1 in E2, we are placing letter 1 in E1 means one complete, all possible D arrangements are one only, because this both you have to consider together. If you arrange together, both letters if you arrange together, then only you consider it as a D arrangement. That's why don't take this and this separately. So combined together both of them you have arranged in one improper way. We have arranged in one improper way. Are you clear? Okay. Now coming to this, suppose 2 objects are arranged, D2 is nothing but 1. Suppose if you arrange 3 objects, suppose all 3 letters are in wrong ways, means in wrong envelopes. In that particular case, what it is? If we count like this, it is a time taking process. Okay, D3 also we can guess, but D4, D5, D5, D6, okay, whenever you increase the number of objects, this is not a suggestible way. So what I will do here, it is directly I will give you dearrangement formula, dearrangement of n objects. Okay, dearrangement of n objects. Dearrangement of n objects is nothing but dn. dn is equal to n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus and so on minus 1 whole power n into 1 by n factorial. This is a formula for the dearrangement of n objects. Suppose if you take 2, dearrangement of, why 2 we are taking? To write the improper arrangement, to know, to say the improper arrangement, particularly to represent improper arrangement, minimum 2 objects required. Suppose only one letter is there, only one envelope is there, by default we can arrange in proper way only. So for dearrangements 2 objects required. So D2 is equal to apply. D2 means 2 factorial into 1 by 2, you can stop here only. For D3 you have to stop at 3 factorial. For D4 you have to stop at 4 factorial. Like this, that is nothing but 1. Already we have verified practically, that is 1. It coincides theoretically also or not? Yes. Similarly, if you apply D3, this formula, that is 2. You can check it later. D4 means dearrangement of 4 objects, that is you will get 9. Dearrangement of 5 objects, that is 44. Now here 5 DFC. There are 5 different letters and 5 addressed envelopes. If the letters are put at random in envelopes, the probability that at least one letter is placed in correct addressed envelopes. So this will be helpful for the numerator. D5 will be helpful for the numerator. Now first we have to fix the denominator. What is the denominator? All possible arrangements. Wrong or right, you leave it. All possible arrangements you have to write in denominator first. That is solution. What is n of s? N of s is equal to, very clear. Simple. Here also answer is 5 factorial, but how it comes I will show you clearly, you see. There are suppose 5 letters and 5 envelopes. For the, suppose you just assume these are 5 envelopes. Okay. For the first envelope, how many letters we can place in first envelope? How many letters are available to place in first envelope? 5 letters are available. And because task we are continuing the task in sense and operation, means the product. In second envelope, how many letters left? 4. So second envelope we can arrange with any of the 4 letters. It can be done in 4 ways. And third 3, 4, 2, and only 1 left for the last one. So 5 factorial. This is the denominator. Don't confuse. Denominator is the all possible arrangement. Numerator is the favorable case that which comes from the question. Okay. Now this is 5 factorial. Now what is the question? At least one letter is properly placed. P of at least one is properly placed. Yes, probability of at least is nothing but 1 minus probability of none. This is the simple way. At least 1 means I have to start from 1 or more than 1. Okay, P of 1 or P of 2 or P of 3 or P of 3, P of 1 letter or P of 2 letters or P of 3 letters or 4 letters or up to 5 I have to go, time waste. Don't do like this. Probability of at least 1 is always 1 minus probability of none. That is 1 minus P of no letter is properly placed. No letter is properly placed. Is it? That is 1 minus denominator 120. Probability of no letter is properly placed means D5. Okay, dearrangement of 5 letters. Dearrangement of 5 letters is 44. Okay, 120 minus 44, that is 76 by 120. 76 by 120 means which option is right? 19 by 30. Is it? Option B is correct. Are you clear? This is dearrangement, sir. This is the way. Next, a point xy is selected randomly in a plane where 0 is less than or equal to x is less than or equal to 1. 0 is less than or equal to y is less than or equal to 1 means you see this. This is 0 x-axis, y-axis. Suppose if you take 1 here, on y-axis if you take 1 here, you can take any value of x from 0 to 1. If you take any value of y from 0 to 1, means what it is, this is 1 in the sense, means this is y. So, like this. A point xy is selected randomly in a plane. You can take a point xy randomly here. That, but maximum value of x is up to 1, between 0 to 1 only. Maximum value of y is up to 1, that is in between 0 to 1 only. Means no doubt you can take any point xy, you can choose any point xy randomly here. So denominator is the all possible points within this portion. All possible points within this portion means how many points are there in the portion? Infinite number of points. Will you take infinity as a denominator? No. Already I told you in the beginning, to solve some problems, area concept is helpful to you, so that you can take the denominator is a total area of this portion. Total area of this portion means what it is? Is it a square or not? No doubt it is a square. Okay. Total area of this portion, it is a square. Okay. It is a square. Okay. What is the square area? This is 1 unit distance. This is also 1 unit distance. So n of s is nothing but area of a square. Area of a square, what is the area of a square? That is nothing but 1 into 1. That is 1 square unit. Is that right or not? 1 square unit is the area of a square. Now coming to the numerator. Numerator always comes from the question. What is the question here? Find the probability that the selected point satisfies this condition. Selected point satisfies the condition means that is p of x square plus y square is less than or equal to 1 by 4. X square plus y square is less than or equal to 1 by 4 means what it is? P of x square plus y square must be less than or equal to 1 by 4 means this is nothing but, see, x square plus y square is less than or equal to 1 by 4 is a condition. Okay, that is nothing but x square plus y square is less than or equal to 1 by 2 whole square or not? Is it a inside portion of the circle or not? What is x square plus y square? See, this is a circle. This circle is nothing but x square plus y square is equal to 1 by 2. Actually, this region, this circle, this boundary is nothing but a circle x square plus y square is equal to 1 by 4. But less than or equal to 1 by 4 means what it is? Inside the region. But complete inside region is not our favorable case. What is our favorable case here? Our favorable case is not complete inside region. Our favorable case is nothing but part of the denominator only. Means 1/4 of the shaded, 1/4 of the area of a circle. So what is n of e here? N of e is equal to 1 by 4 into area of a circle. What is the circle? X square plus y square is equal to 1 by 4. That is nothing but 1 by 4 into what is the area of circle? Pi r square. What is r square here? 1 by 4. That is nothing but pi by 16. Therefore, what is required probability? Required probability is nothing but, tell me what it is? Pi by 16 by 1. Pi by 16 1. Which option is right? Option C is right. Okay. Now coming to the conditional probability. If E1 and E2 are two events of a sample space, then the conditional probability of an event E1 after the occurrence of E2, okay, means suppose one event already occurred, we using that, okay, based on that we are finding the probability of E1, the conditional probability. See, suppose one condition given to you, already occurred event we can take in denominator, using that then the probability of an event E1, how can we define in sense P of E1 by E2 is equal to P of E1 intersection E2 by P of E2, provided, yes, denominator should not be 0, because if the denominator is 0, it is not possible to define. Now if you cross multiply it, that is P of E1 intersection E2 is equal to P of E1 by E2 into P of E2. We call it as multiplication theorem on probability. But why this definition helpful to you, how it is helpful to you with one simple example. Actually don't think it is a special definition, separate definition. To solve some problems easily, this definition is helpful to you. But how this definition comes, I will give you one simple example. For example, you see, I will justify the definition with one example. If a card is drawn from a, from a pack of 52 cards, if a card is drawn from a pack of 52 cards and the card is already red card, find the probability that, suppose if I ask a question like this, find the probability that it is a king. Okay, try to listen carefully, try to follow carefully. Here, the main reason for the conditional probability definition I will explain here. If one card is drawn from a pack of 52 cards and the selected card is already red card, we know already condition given, what you have selected, that card is already red card. Find the probability that it is a king. So probability that the card is a king is nothing but K means king. Denominator you need not take 52 here, because already what you have selected, it is a red card. Already it is a red card means denominator is 26 only, denominator 26. Now coming to the numerator, what is numerator? Okay, denominator is 26. Now numerator is, it is already a king. Okay, now king means already in, see, king means actually 4 kings are there. One diamond king, one heart king, one club king and one spade king. But it is already a red card means, what are red cards? Hearts and diamond. Heart king and diamond king only you need to consider, that is 2 by 26. 1 by 13 is the answer. Actually here condition given. No need to use the conditional probability definition, no definition required, no condition required. Logically you can answer the question. But the thing is, every problem is not so easy like this. Some problems, in some problems this condition may be complicated. Okay, so every problem not possible to think like this. That's why if you use this definition is very much helpful to you to save your valuable time. Okay, same problem, okay, how to, that conditional probability link I will give you from the same problem you see. Okay, or if a card is drawn from a pack of 52 cards, the card is already a red card, See, already occurred event I will take in denominator. Find the probability that it is a king, P of K by R, same, simple. Same answer, that 2 by 26, instead of writing this 1 by 13, what I will write, you see. 2 by 52 I will take, 26 by 52 I will take. For my convenience to define this conditional probability definition, okay, just same solution I am converting like this. What it is? 2 by 52 means what it is? 2 cards. See, first 26 by 52. 26 by 52 means 26 red cards among 52 cards or not? This is nothing but the probability of red card or not? Denominator is the probability of red card. Now numerator is nothing but 2 cards among 52 cards. There are 2 kings out of red cards. Okay, total red cards, from the red cards there are 2 kings. Okay, this 2 indicates 2 kings which are from red cards. This 2 indicates 2 kings which are from red cards. Means that is a combination of king and red cards or not? Red cards who are kings also, there are 2. Kings who are red cards, there are 2. So same problem you can represent like this, P of K by R is equal to P of K intersection R by P of R. Okay, same answer or not? But this is easy. If you solve like this, this is easy. But every problem, it is not so easy like this. That's why better to use this definition to solve some problems easily. P of k by r is equal to P of k intersection r by P of r. This is nothing but the conditional probability definition. P of already occurred event you can take in denominator. Numerator is nothing but P of E1 intersection E2 by P of E2, provided P of E2 is not equal to 0. Because of this particular reason only this definition was given like this, to make the solution easy, is it? Okay. Now coming to independent events. Events in a sample space are said to be independent if the happening of one does not depends on the happening of other. Means if one event is not depending on other event, then the events are independent events. Okay. If 4 persons are hitting a target, okay, for example you see, if 4 persons are hitting a target, suppose one may hit, suppose if it is a gun shooting competition or shooting competition or archery competition, suppose if 4 persons are shooting in shooting competition, one may hit a target 4 out of 5 shots, and second person may hit a target 3 out of 5 shots, and third person may hit a target 5 out of 5 shots, like that. So no one, no doubt it is a skill based. Okay, one person's skill is not depending on the second one is not depending on third one. All are having different skills, every person's skill is independent. So like this, if 4 persons are hitting a target, then every outcome is independent. If a coin is tossed n times, then the result of every outcome is independent. Suppose if you toss a coin one time and you observe the outcome, and same coin you can toss it again and you are repeating the experiment. Second outcome is not depending on first outcome. The second result will not depend on the first result. Third result will not depend on the first 2 results, like that. Okay. Now some examples, many examples we can give like this. Next, if E1 and E2 are independent, in that case, suppose if E1 and E2 are independent, so here what is the meaning of P of E1 by E2? P of E1 by E2 meaning is conditional probability of E1 after the occurrence of E2. Since here, but in this particular case, if E1 and E2 are independent, here E1 need not depending on E2. Even if you find P of E1 by E2 also, no use, that will be equal to P of E1 only. So in case of independent events, P of E1 by E2 is equal to P of E1 directly. No need to apply the conditional probability definition in this particular case. That is P of, in this particular case you see, what is conditional probability actual definition, here it is. So whenever the events are independent, P of E1 by E2 is equal to P of E1. Therefore P of E1 intersection E2 is equal to, in case of independent events it will be like this. P of E1 by, in place of P of E1 by E2, P of E1 will come like this. Are you clear? Okay, now coming to some problems on independent events and conditional probability. A hydraulic structure has 4 gates which operates independently. 4 gates which operate independently. The chance of failure of each gate is 0.2. If the first 3 gates are already failed, then find the chance of failure of 4th gate also, 4th gate. Okay. Now you say this, you need not put your pen on paper. One hint given. A hydraulic structure has 4 gates, all are operating independently. All are operating independently means the failure of each gate does not depend on the failure of the remaining gates. So the chance of failure of each gate is given as 0.2. First 3 gates are already failed. What is the chance of failure of 4th gate? Since all are operating independently, failure of 4th gate need not depending on the failure of the first 3 gates. Directly you can write the chance of failure of 4th gate. Since the chance of failure of each gate is 0.2, what is the chance of failure of 4th gate? That is also 0.2. Are you clear? If A comma B are independent events such that S is equal to A union B and P of A is equal to P of B, then find P of A. Then find P of A. Okay, say this. Solution. One hint given here, A comma B are independent and S is equal to A union B given. Given, what is given? S is equal to A union B. Take probability on both sides. P of S is equal to P of A union B. What is P of S? 1. What is P of A union B? Apply addition theorem. P of A plus P of B minus P of A intersection B. P of S is 1. Take probability on both sides. Since P of S is 1, I have written like this. P of A and B, apply addition theorem. That is nothing but 1 is equal to. Since events are independent, in previous, already I told you in previous slide, if the intersection, whenever the events are independent, you can write P of A intersection B as P of A into P of B. That is nothing but P of A plus P of B minus P of A into P of B. Since A and B are independent given. And one more hint given. What it is? P of A is equal to P of A given. That is 1 is equal to P of A plus P of B minus, P of, in place of P of B also you can write P of A minus P of A whole square, because P of A into P of A, that is nothing but P of A whole square, P of A, that is nothing but 2 P of A, if you write this side, minus 2 into P of A plus 1 is equal to 0. This is in a form, once you say this, x square minus 2x plus 1 is equal to 0 or not? That is nothing but x minus 1 whole square is equal to 0 or not? X is equal to 1. In place of x, who is there? P of A. Therefore, P of A is equal to 1. Which option is right? Option C. Is it? Now coming to the next problem. The probability that man passing an examination is 1 by 2. Probability that man passing and getting more than 80% of marks is 1 by 3. You see this. Don't confuse here. Okay, this problem is related to conditional probability. Immediately, whenever the problem given like this, I will write to avoid confusion, I will take these two events as, I will symbolize these two events. The probability that a man passing an examination, suppose you see solution how I am writing. Let capital A is equal to event, this event is man passing an exam. I will take like this. Capital B is equal to, that is event, the probability that a man passing and getting more than 80%. Okay. Man getting more than 80%. Let event capital B like. Now given data, the probability that the man passing an examination is 1 by 2. What is given? Given probability that the man passing an examination means P of A is equal to 1 by 2. And the probability that man passing exam and getting more than 80%. Both passing and getting more than 80% means, is it intersection or not? P of A intersection B is given as what it is? 1 by 3. Okay. Next, you see, if a man passed the examination, see condition given here, you see clearly, already he passed the examination, already occurred event, I can take in denominator. If a man passed the examination, as man passed the examination means that is A. Already occurred event, you can take in denominator. Find the probability that he gets more than 80% of marks. He gets more than 80% of marks means what it is? Getting more than 80% means that is B by A. That is, what is conditional probability definition? That is P of A intersection B by P of B. That's why I say this. How conditional probability definition is helpful to you means to avoid confusions like this. If you apply the conditional probability definition, you can solve the problem very easily. What is P of A intersection B? 1 by 3. What is P of B? P of A given, or sorry, P of A, denominator P of A, by mistake P of B. P of A intersection B by P of A. What is there in the denominator that you have to represent here? P of A is 1 by 2. Final answer is 2 by 3. Very clear? You see, if A comma B are two events of a sample space such that P of A is equal to 1 given, P of B is equal to 1 by 2 given, then P of A by B and P of B by A respectively are solution. P of A is equal to 1 given, P of B is equal to 1 by 2 given, 1 by 2. P of A by B required for me. What is P of A by B according to the definition of the conditional probability? P of A intersection B by P of B. Next, P of B by A also required for me. What it is? P of B intersection A by P of A. Is it? P of B intersection A by P of A. That is nothing but P of A and P of B are available, but P of A intersection B is not available. P of A intersection B is not available, but how to find a solution? One hint given you see here. P of A is equal to 1 given means here A is nothing but a sample space. Probability is 1. It is possible for sample space only. P of A is equal to 1 means no doubt A is nothing but the universal set. It is a sample space. Here A is a sample space. A and sample space both are same. So every event, whenever A is a sample space, every event must be a subset of the sample space. So no chance B must be a part of A. B is a subset of a sample space clearly. Okay. B is a subset of S. Now, whenever B is a subset of S, what is A intersection B? Okay. A intersection B is nothing but the common portion. So clearly B is a subset of A means A intersection B is nothing but B only. Intersection is nothing but the common portion for both A and B or not? That is nothing but B only. So that implies what is P of A intersection B now? That is P of B. That implies P of A intersection B is nothing but P of B. What is P of B? P of B is nothing but it is given as 1 by 2. Now coming to answer this question, P of A intersection B is 1 by 2. P of B is also 1 by 2. That is 1. P of B intersection A, that is 1 by 2. What is P of A? P of A is 1. That is 1 by 2. 1 comma 1 by 2 are the answers. 1 comma 1 by 2 means option D is correct. Is it? Now coming to this. The page numbers of 100 pages book are marked with the numbers 00, 01, 02 up to 99. Means you see, first page is printed as 00, second page is printed as 01, third page is printed as 02. Like that, 100th page is printed as 99. If capital X is the sum of the digits of each page number and capital Y is the product of digits. Okay, capital X is the sum of the digits and capital Y is the product of digits. If a page is selected at random, find the probability that capital X is equal to 9 if Y is equal to 0 for the selected page. Means what it is? Suppose capital X is the sum of the digits of each page means suppose if you choose a page number 23, capital X is nothing but for page number 23, capital X is nothing but 2 plus 3. Capital Y is nothing but 2 and 2 into 3. You have to understand like this. Okay, capital X is the sum of the digits of each page number and Y is the product of it. One page is selected randomly from the book. Find the probability that X is equal to 9 if Y is 0. If Y is 0 means how to understand? If the product of that page, if the product is already 0, if the product of the digits on the page is already 0, find the probability that the sum is 9. Product is already 0, already occurred event. Means what is the solution here? So conditional probability here also condition given. P of Y is equal to 0. Sum is 9, X is equal to 9. Okay, what this is in a form P of A by B or not? Okay, what is P of A by B? That is nothing but P of X is equal to 9 intersection Y is equal to 0 by P of Y is equal to 0 or not? P of Y is equal to 0 or not? Yes. Now you see, now how many pages which gives a product 0? Y is equal to 0 cases I am writing. Page number 00 gives the product 0 or not? Page number 01, 10, 02, 20, 03, 30, 04, 40, 05, 50, 06, 60, 07, 70, 08, 80, 09, 90. All these pages gives the product 0. All these pages gives the product 0 means 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to 18 pages here means 0, 1 and 1, 0 both you have to count. 18 plus 1, 19 pages. Denominator is nothing but 19 by 100. Numerator means sum 9 and product 0 parallelly. Sum 9 and product 0 means these two cases only. 0, 9 and 9, 0. These two only gives. 2 pages out of 100 pages. That is 2 by 19. Is it? 2 by 19 is the answer. Which one? Option C is correct. Okay. Today's session, okay, tomorrow we'll continue tomorrow. I want to wind up the today's session, and next session will continue tomorrow at 7 o'clock in the evening. I hope you all followed these concepts and problems clearly. These problems and concepts definitely, if you follow clearly, these are helpful to you, okay, for GATE and remaining any other competitive examination also. Okay.